the way the short course is set up, we spend the first part of our 2.5 days together learning about confirmatory factor analysis, learning about the distinction between latent variables and indicators, and how to build measurement models, how to test for dimensionality, how to test for the presence of higher order models. And all of that, that technology and statistical information is important background in terms of understanding structural equation modeling. But the point is that for many, if not most people, the interest is relatively less on measurement types of issues, and theories exist that say more than just latent variables are correlated with each other, or that correlations amongst latent variables can be accounted for by higher order factors. And instead, most of our theories end up identifying exogenous latent variables for which we have direct measures or indicators, and models propose that those exogenous latent variables are related to other endogenous latent variables in a way that is representing some type of structural or causal influence. And then also these types of models propose that even amongst the endogenous variables, that there can be, quote, these types of causal relationships. Those are the types of theories that most researchers in social and organizational studies areas work with. And basically, what we've been doing is trying to build the skills and knowledge to bring us to the point where we can now learn how to evaluate those types of models. We have two exogenous latent variables and two endogenous latent variables. I have quite creatively labeled them X1, X2, where the X is for exogenous. And let's remember that what makes them exogenous is that there are no arrows going to those latent variables. That's by definition what an exogenous latent variable is. Alternatively, we have two additional latent variables that serve as dependent variables within this particular model.
In your analyses really represents the construct anymore, and that's the whole issue here. And so that led us up to this slide that's in front of us. You know, if we want to study the change or the dynamic processes of of the things that we're interested in, what do we use? Well, we need something that, again, I'm going to repeat here just to kind of then start moving forward with stuff. But we need something that describes, again, whatever our unit of observation is, trajectories of change. And so I kind of pointed to a lot of people yesterday. You know, we need a technique that pulls out our individual change trajectories on whatever variables we're interested in. And these variables could be the independent variables, they could be the dependent variables, and I should put and or the dependent variables, and or moderators, and or mediators. Later on today, when we go into multi-level structural equation modeling, you can have these change variables not only at the individual level, but we can bring them up to the team or work unit level. So we could look at LGM there based upon vectors of change down here. You can take two vectors of change and make an interaction out of them, a latent interaction. So we could make hypotheses that says the impact of change on this variable on the other one is dependent upon the level of change on a third variable, a Z variable, for example, moderator. We could look at them in mediating relationships. So we could talk about full mediation in the sense that the impact of change on our X, on our Y variable over here, is fully mediated by the change in another variable over here, okay? Or is partially mediated. There could be both a direct or an indirect effect through the other one. So the point here is that once we have identified these vectors of change, we can make a latent variable out of it, you know, the mighty ellipse.
Even before you look at the graph, although based on Tukey's work, we know that it's always a very good idea to look at graphs before you analyze the data, you can understand the shape of that relationship between x1 and y by looking at the signs of the first term and the second term in the equation. If the first term is negative and the second term is positive, that is the kind of line that you expect to see. And the way to think about these lines is, well, we start with a linear trend, which in this case is negative, but then we have a positive nonlinear turn. So the curve tries to become positive. Here, we start with a positive linear trend, and then it becomes even more positive. In this case, we start with a negative trend, and it becomes more negative with considering the quadratic term. And finally, we have a positive linear trend, but then, because of the negative quadratic, it turns that way. So what we argue, Jason Pierce and I argue in that paper, is that, sure, it's important to understand if we have a linear trend in the data. However, eventually, if we go higher and higher along the x-axis, eventually it is likely that that relationship will turn nonlinear. So we need to understand, where is that inflection point? Where is that? Where does a trend change from being linear to neutral, or changing from positive to negative or negative to positive? Because if you believe from a practical standpoint that increasing x1 will give you more and more of the goodies, you will get more and more benefits, let's say more firm growth, faster and faster and faster growth will lead to more and more and more profits, you will continue to accelerate the growth of the firm. But at some point, you may see that that growth is too fast for your situation, and you may not get the results that you're anticipating, or you may even get negative results. The same thing with individual traits. One of the examples we give in the paper is the example of conscientiousness. And there's a linear relationship between conscientiousness and job performance. But at one point, being too conscientious on the job may lead to rigidity, or maybe lack of creativity, or maybe paying attention to the letter of the law as opposed to the spirit of the law. And that may lead to no further improvements in performance, or even, perhaps, a negative relationship eventually as well. Again, that's what we call the too much of a good thing effect. And that effect, the presence of that effect, can be tested in your data set using a regression model that includes a quadratic term.
Which of those predictors were significant? So we would like to report in the journal article or in our own analysis what was significantly related to job satisfaction. And here we see that positive affect was, so higher positive affect, higher satisfaction. Negative leadership, so people rated their leaders very negatively, they had lower job satisfaction. Pay was positively related. Higher workload, lower job satisfaction. The higher the cohesion of the unit, the higher the job satisfaction. Here you can see again the degrees of freedom represent the group. Task significance as a group level was unrelated right here. So you would, obviously, that's what you're looking at when you start to add these predictors in. This is just like doing a regression equation.
Can we just go back to interpretation?
Sure.
So our DB is individual level job satisfaction. So go through again with the significant group, like cohesion group.
So this would really be, and you kind of caught me slipping up on the thing I told you not to do. Would be,
I'm not catching you, I'm just trying to.
This would be average level of cohesion within a group. Okay, cohesion would be related to the average level of job satisfaction within a group.
So this even though our individual factor is our DB.
Your individual factor is your DB, because you're explaining tau sub 0, 0, all you can explain is the group level variability.
Okay.
And that's why this degrees of freedom represents 47. This is like a group mean analysis where you took the group means for cohesion the group means for job satisfaction, even though you never explicitly created the group
Yeah,
means
that's
for
what-
job
okay.
satisfaction, okay? But it broke job satisfaction into the two parts, the individual part and the group mean part. And so it's simultaneously doing a group mean analysis, controlling, if you will, for all of these individual.
And so, what does that tell us? It tells us when we're writing this up, we want to be thinking about what would be some additional level 1 predictor variables we might want to include in future studies to try to further explain some of that within groups variance that we were unable to explain. We explained a lot of it. We had a really big within groups variance. We included mood and it shrunk it down, but there's still some significant variance left that we want to explore.
Would you have to add level 1 predictors, or would you add more level 2 predictors to help
To,
explain?
very good question. To reduce that sigma squared, that 5.61 value has to be level 1. It's going to be the within groups variance. When we move to the, and these values correspond exactly to what's on the HLM output that I gave you on, where's that page? 12, the last page of HLM. So 5.61, 5.61. In terms of the variance in intercepts, that's still significant. We knew that was significant from last time. The implication for that is if we have additional level 2 predictors that we want to test, let's test them now. If not, we need to be thinking from a programmatic perspective, what do we want to test in the future that might help explain some of the variance in intercepts. So we know that the variability that we see driven by this is still greater than 0. It's still significant. Yeah.
We've talked about this a little bit, but I mean, and throughout this entire process, you're looking at significance, but there's practical significance, there's statistical significance, and in Paul Bliese's class, it seemed like in some instances you could be more lenient with the P levels, where you wouldn't necessarily, if you got 0.09 or 0.1 or maybe even a 0.2 in some instances, that wouldn't necessarily stop you from proceeding. Is that, I mean, how consistent are the use of p-values in this whole process compared to other research approaches?
My experience is that it's been reasonably consistent. But you can make argument, I mean, I think if you've got good reasons, you can make an argument to adjust your p-values. I mean, we've made arguments.
So like in other research, you can make a good argument why you wouldn't necessarily stop at 0.06.
Yeah. I mean, we've made arguments when we're testing for interactions, for example, using moderated multiple regression, that given the statistical difficulties associated with detecting those sorts of interactions, we're willing to trade off a type 1 and a type 2 error, and we'll jack up the p-value to 0.1, but only for the interaction. In terms of the practical significance, you get a sense in some degrees of that with the quasi-R squares. These are basically effect size estimates, so it gives you a sense of how much of the variability that did exist in these slopes are we now explaining with the inclusion of this cohesion variable.